Hello and welcome to Moving Forward. I'm your host, Rachel Salyer. The University of Akron's most recent ad campaign focuses on the energy of innovation. Today we'll be speaking with several people who helped inspire this campaign. Later this episode, we'll be speaking with Dr. Todd Blackledge about his research involving spider silk, and two students, Courtney Gross and Tom Vo, about their efforts to use clean energy. But first, with us now is Dr. Jun Hu to talk about the innovative new device for monitoring diabetes. Thanks so much for being with us today.
Thank you.
Now, can you first briefly explain to us how this device works?
The device basically is a piece of hydrogel, and it does not necessary to be a contact lens, but it needs to be bathing in tear, because in tear we have about 1/15th or 1/20th of blood sugar, which can be sensed by this material. Mm-hmm. And we have a dye and also a molecule that binds to the sugar molecule. It's a sugar sensing molecule, so that we created a mechanism such that it behaves like a pH paper, mm-hmm. so that when the glucose concentration varies, and the color will change reversibly. And this changing in the sugar level in the body can be captured by a camera. Basically, you can use a cell phone camera to capture that change, and the camera cell phone will be able to quickly calculate the actual concentration based on stored data in the camera.
So could this potentially eliminate the need to prick your finger to test your blood sugar?
Yes, but that's not our goal. I mean, it will eliminate most of the the blood sensing with the lens, and to take the plasma sample, and it's really not conflicted with this standard. Nowadays, typically, you take 3, 4, 5, 6, or times of the blood sugar levels. But with our device, maybe you only need to take once a few days or once a day, that you're serving as a calibration point, almost like a continuous measurement of your blood sugar levels.
And how did you first come up with this idea?
When I started here 10 years ago, I was interested in analyzing sugars, understanding the different structures of sugar in terms of analyzing the precise sequences and the properties of these sugar molecules vital. But it's very difficult to do. It's probably the most challenging analytical problems in science, in chemistry, because sugar molecule it does not have chromophore. In other words, it's completely clear, and you dissolve a sugar in water, it's just clear. You don't see color, and so we initially think that we need to make sugar color, mm-hmm. to tell the difference between very similar molecules. We start to thinking about creating molecules mimicking the molecular recognition properties of natural enzymes, natural antibodies. So this is where it all started. We were hoping to create a material that can sense glucose, but also will allow us optically detect the change of the glucose. And we believe this will be more accurate and more last much longer. So we basically 10 years ago we started thinking about this problem, and we have really a whole program to tackle this sugar analysis and the real-time sensing of glucose.
What is the long-term goal for this technology?
There are two basic goals. One is the device is actually very affordable comparatively to the electronic detections. So the first goal is we can create a material that can be used for people as a diagnostic tools. There are a lot of people, they are diabetic, they don't know, they have no symptom, or pre-diabetic. Their blood sugar is already high. And it is a good idea to have a continuous monitoring, at least for a few days. This will provide a device that we can sell in, like for example, any drugstore or Walmart or anything, that people suspicious of their sugar levels, they can buy one, maybe $5, and they will be able to wear it, and they know their blood sugar levels, and before even they go to doctors. And this not only will help people to do early diagnosis, but also will increase the awareness of diabetes in the general population. The other goal, of course, is that for people require insulin, it is important for them to monitor the sugar levels very often. We're not intend to replace the fingerprint because that's sort of golden standard, and it takes the blood directly from the plasma.
And so what exactly happens when a high blood level is detected in the device that you're developing now?
First of all, the color change. If you look in the mirror or somebody sees it, it will tell you, okay, it shows a red dot, for example. That you can always see it. You can always tell it. And the other thing is that this is quantitative. It will tell you exactly how much sugar level it is, and that will provide information for example, how much insulin you need to inject, and how many units, and the software will also give you warning signs. So it does give, the computer basically will tell you what to do.
And how soon do you hope to release this technology to the public?
Right now, we were able to demonstrate the principle in the laboratory. And last year, I discussed with the FDA, says, okay, I have a device coming that may allow us to, do the glucose sensing non-invasively, and you can do it as many times as you can, as you wish. And right now, the small molecules, the sensing molecules, still leaches out into the eye. Okay. So they basically require me to make sure that nothing leaches out from this piece of hydrogel material. So if everything works out, maximum 4 or 5 years, we will get on the market.
Well, thank you so much for joining us today, Dr. Hu, and we look forward to seeing this technology on the market very soon.
You're very welcome. It's my pleasure.